Here we are going to give examples for assignment number 5 for math 1 to 2, which deals with geometric distribution. So we started with number 1. So here's number 1 in the assignment, and here is an example we are going to set. Here we are analyzing a random variable x that approximates the geometric distribution with a probability of success of 0.85. And we are calculating what is the probability of succeeding on the 5th trial. So the formula we are going to use is taken from unit 5, and here it is. P of x equal r is equal to q raised to the r minus 1 times p. Q is equal to 1 minus p. So r for us here is 5 and p 0.85. So this will be equal to 1 minus 0.85 raised to the r minus 1. R is 5, so r minus 1 will be 4 times p, which is 0.85. So we can use two of one things. One of two things, we can type in Google geometric distribution calculator online. So I've tried this too, and preferably I would use this one, the quick geometric distribution calculator. And or probably here's the formula. There it is. Probability of succeeding on the CAPE trial. Okay, so that'll be 0.85 for probability of success, and or R is 5. Here they are using K instead of R, where K is the number of trials. So this calculator giving us an answer of 0.00043, and they are even giving us the answer of less than 5 at the same time. Okay, probability of succeeding in less than 5 or less than or equal to 4, if you want to put it that way. All right, and so what we can do now, we can actually go to a normal calculator and apply the formula. 1 minus 0.85 is 0.15, so that'll be 0.15. Raised to the 4 times 0.85, and we're getting 0.00043 for our answer. Well, probably that you succeed in more than 4, so we can use more than 5 here. Again, let's check all the formulas that we've got. More than r will be q to the r. So that would be 0.15 raised to the 5. That'll be failing 5 times, if you want to put it that way. Succeeding in more than 5 is like failing 5 times. So that'd be 0.15 raised to the 5. 0.15 raised to the 5. That'll be 0.0076. For part C, The question says probably that you succeed within 2 trials. And here I have within 3. So let's see what formula we can use for that. Within R, that will be 1 minus U of X more than R, that is not succeeding above R. That's, you can interpret it that way. And that's 1 minus Q of R. So that would be 1 minus 0.15 raised to 3. So 1 minus 0.15 raised to 3. That's 0.9966 approximately. No, but this is asking what's the probability of succeeding in more than 8, given that, you succeed in more than 3. Okay, so basically you have to apply the conditional rule formula here. The conditional probabilities is given by this formula. That's the probability that probability of B given A is the probability of B and E over the probability of E. That is where they intersect. Okay, given E. So we have to look to see where those two probabilities intersect divided by the condition. So that would be equal to the probability where those two events intersect symbol for intersection. Here it is. Over the probability of the condition, which is probability of succeeding more than 5. So given that you succeed in more than 5 trials, what is the probability that you succeed in more than 9? So where does more than 9 and more than 5 intersect? More than 5 and more than 9 intersect in more than 9. Okay, that's where they meet. We can use a number line to prove that. So here we have more than 5, given more than 5, and more than 5 is from 5 straight across towards infinity. And more than 9 is from 9 straight across also to infinity. So more than 5 and more than 9 intersect at more than 9. Okay, that's where they meet. Hence, the formula is simplified to more than 9 over more than 5. Okay. Now more than 9 now is q raised to the 9. And more than 5 is q raised to the 5. So that would be 0.15 raised to the 9 over 0.15 raised to the 5. And that would be simply 0.15 raised to the 5. Because that would be 0.15 raised to the 9 minus 4. Oh, and look, we have 0.15 raised to the 5. We just calculated it here, coincidental. So that's the answer for this question.